Okay, hi guys, welcome to my YouTube channel. If this is your first time, please like, share, and subscribe. By the way, we'll be looking at some topics in further mathematics and additional maths together. So, further mathematics for WAEC and additional maths for IGCSE for O level. That's what we're looking at together. So, for today, we want to look at functions. We want to see what functions are. You've heard of functions before? What is the function? So I'd like us to talk a little bit about functions. Probably you've seen something like this before. You've seen f of x equals to, let's say, 3x plus 2. This is the function. It comes in that form. What does it mean? And how can you play around with it? Because our essence here is so that at the end of the day you can play around with things like this. So now, looking at functions, first of all, we like to look at what does it mean? What does function mean? What do we mean by functions? A function is a rule. A function is a rule or a relation that assigns an element in one set to an element in another set. Please take note of that. It is a rule or relation that assigns an element in one set to an element in another set. So we have two sets here. We have, let's say this is the first set. This set, let's call it input set. Then we have another set here. Let's call it output set. Now, if I have an element here, let's say A, then we have a rule or a relation. Take note of that. We have a rule or relation that assigns an element. I have an element here A, let's say I have an element here N. I have a rule that assigns element A here to element M here. If you have such a rule, then we call that what? That rule is what we call function. A rule that assigns an element from the input set to an element in the output set. That rule is what we refer to as a function. Now, take note of this word, rule or relation. In mathematics, anytime we hear the word rule or relation, where should your mind go back to? Your mind should go back to what? An equation. A rule or a relation in mathematics is majorly an equation. So please, anytime you hear that word rule or relation, know that it's an equation you're dealing with. For example, take a look at this function we have. This function. This function will take an input element x. When it takes an input element x, it will give us an output f of x. X is the input element. It will take any value of x as the input value, then give us an output of what? F of x. So if, for example, if my x is, let's say my x is equals to 2, what will be my output? My output will be f of 2. That will be 3 times 2 plus 2. 3 times 2 plus 2. What is 3 times 2? That's 6. 6 plus 2, that will give us what? 8. So for an input of 2, you get an output of what? 8. So let's say you have your input value, you have your output value. So from here, my input of 2 for this function here give us an output of what? 8. Now, if I take an input of, let's say my x is minus 1, what will be my output? So I'll have f of minus 1. That will give me 3 times minus 1 plus 2. What will that give me? That will give me minus 3 plus 2. And that is minus 1. So an input of minus 1 will give me what? Will give me minus 1 as an output. So this is what we mean by a function. It takes an input set and give you an element. It takes an element in the input set and give you an element in the output set. Now please take note. This input set here has a name. Then the output set also has a name. The input set is called domain. The input set is called domain. Set of all possible inputs is called the domain, while the set of all possible outputs is called range. Set of all possible inputs, domain. Set of all possible outputs, range. Now, I believe that is clear. Now, an element in the output set, which is assigned an element from the input set is called image. So for example, in this case now, M is an image of what? A. This M here is an image of A because M is assigned to what? Sorry, A is assigned to M. So since A is assigned to M, or A is mapped to M, so M is called an image of what? A. So like in this case now, for this particular function we had here, if I have an input of 2, I get an output of what? 8. I have an input of -1, I get an output of -1. So it means that this 8 here, the 8 here, is an image of what? 2. And -1 here is also an image of what? -1. Are we good? Alright. Now, this is briefly what we can say about functions. We mentioned what a function is. A rule or a relation that assigns an element from one set called the input set to another set called the output set. And we've agreed that the input set is called the domain, while the output set is called range. Although there are cases, an output set can also be called codomain. But for now, we are going to look at the difference later between codomain and range. What's the difference between them? Now, we want to look at how to represent functions. There are different ways of representing functions, by the way. One of the ways of representing functions is what we call mapping diagram or arrow diagram. Mapping diagram, so representation of functions. Representation of functions. One of them is mapping or arrow diagram. Mapping or arrow diagram. That's one of the ways of representing functions. How does that look like? So you have a function. Let's say I have two sets, my input set and my output set. So this is my input set X, which is my domain. This is my output set Y. Then I have this. I have my function here F. This function F here assigns elements from set X to set Y. That is what this diagram is telling you. That the elements here are assigned to here. So the elements in set X is assigned to elements in set Y. By the way, take note, what is set X? Domain. What is set Y? Codomain or range. Let's use range for now. Now, let's say I have 2 here. I have -1 here. Then I have 8 here. I have -1. So you have that -1 is assigned to -1. 2 is all assigned to this. So this is a mapping or arrow diagram. This is how it's represented. This is how it's represented. Another way of representing set is set can be represented as in a table form, just like I did. Yeah. Table. You can represent the set in a table form. So like you have there, the set can be represented in a table form. So for example, you have your input set X and your output set Y. That's my domain and my range. Now from here, I'll have that X here, I have 2, I have -1. Then here I have 8, I have -1. So I can also represent my set in a table form like this. Then another way of representing sets we have a set can be represented as what we call set of ordered pairs. Set of ordered pairs. What does that mean? If you still recall how to plot a graph, if you've plotted a graph before, you have the Cartesian plane or the Cartesian grid, where you have your x-axis and your y-axis. Any point on this plane has two values. It has the value for x and the value for y. Now the value for x can be traced down to the x-axis. That's the value for x. Okay, let me call it, okay, x. Then the value for y, we trace it to the y-axis. That's the value for y. Now this value is written like this: value for x, value for y, in a bracket is what we call set of ordered pairs. So this is how what you have here is what we call set of ordered pairs. So a function can also be represented as a set of ordered pairs. So you have it here. I can represent this as 2, 8, where 2 is the value for x, my input value, and 8 is my output value. Then I have -1, -1. That is another way of representing my set. So I can represent a set, my function as a set of ordered pairs. Then also I can also represent my function using a graph. You can represent your function using a graph. And please take note, this is very important when representing function. When you are representing a function on a graph, your x-axis is your domain, while your y-axis is your what? Range. Please take note of that. The x-axis of your graph is your domain. So your x-axis is the input, is where you have your input values, while your y-axis is where you have your what? Output values. So for example, let's say I want to plot these 2 points. My x is 2, let's say this is 2, and my y is 8. Let's say I have this point here. Then I have x is -1, y is, let's say, -1 as well. So let's say it's here. So I can have a line that comes here. So that gives me a line. Now this graph here, this particular line here is for the function. If you still recall the function, what was the function? The function was f of x equals to 3x plus 2. That is what you have. So what is my range here is my x, my domain. Don't forget, my domain is the x-axis, while my range is what? The y-axis. So these are the different ways of representing function. The other ways, but I would just like us to look at these 4 different ways of representing a function. Now, the next thing is, if you are given a function, can you find the domain of the function? Because those are some of the questions that comes up in your WAEC, even IGCSE questions. You're given a function and you're told, find the domain of this function. Can you find the domain of the function? Now the question is, let's look at let's say I have a function. So I want to look at how to find the domain of a function. How to find the domain of the function. So let's say I have a function. G of x. G of x. By the way, if you see a function like this, I didn't really Notation of function. Notation of function. A function can be denoted like um, f of x equals to, they give you a particular equation, or you can also have a function represented this way, f such that x is assigned to. So let me see, let's say f of x is equal to 3x plus 2, or f such that x is assigned to 3x plus 2. So these are two notation of functions. You can represent, if you see this is the same thing as this. And you can also represent it as y equals to 3x plus 2. The three of them mean the same thing. Are we together? It all means the same thing. So these are different ways you can denote a function. Now, let's look at how to find the domain of the function. The domain of a function is generally the set of real numbers. The set of real numbers. I believe you know what we call set of real numbers. If you don't know, let me just give you a brief overview of sets of numbers. So if you're looking at sets of numbers, there are different sets of numbers. So sets is like a collection of numbers that have similar characteristics that are well defined. Now, the first set of numbers is called whole numbers or natural numbers. Although there's a difference between them. There's a difference between natural numbers and whole numbers, but I like putting them together in this case now. So let's call them whole numbers or natural numbers. Now, actually, the difference between them is that for whole numbers starts from 0 to positive infinity. But natural number starts from 1 to positive infinity. So that's just the difference. So I just want to put the two of them as a particular set of numbers. I will present these whole numbers symbolically as this. You can represent it as this. So if you see this symbol in any math textbook, it stands for what? Whole numbers. Then you have integers. What are integers? Integers are made up of positive whole numbers, negative whole numbers, and 0. Positive whole numbers, negative whole numbers, and 0. So that's what we call integers. And the symbol for integers is this. So if you see this kind of symbol in your math textbook, that is an integer. Now, like I said, integer, you have negative numbers, -3, -2, -1, 0, 1, 2, 3. So you have 0 in the middle, positive numbers, positive whole numbers here, you have negative whole numbers here. So this is what we call integers. Now you now have, after integers, you have what we call rational numbers. Rational numbers. These are numbers that can be expressed as a fraction. So any number that can be expressed as a fraction is a rational number. And the symbol for rational numbers is Q. That's the symbol for rational numbers. Any number that can be expressed as a fraction is a rational number. So think of any fraction at all. And I believe you should also know that a whole number can also be written as a fraction. So 3 can be written as a fraction. What is 3 as a fraction? That is 3 all over 1. So that is it about rational numbers. Then we have irrational numbers. Irrational numbers are numbers. These are numbers that cannot be expressed as a fraction. Irrational numbers, they are numbers that cannot be expressed as a fraction. If I want to write them, I can write them as Q prime. Q prime. Numbers that cannot be expressed as a fraction. Then the last of them, what I like to say, the gapata of them, is real numbers. Real numbers. Now, what are real numbers? Real numbers are numbers. Real numbers is a combination of both rational and irrational numbers combined together. So you have a combination of rational and irrational numbers combined together. If you combine the two of them together, you have real numbers. So real numbers has a symbol, this, real, R. So if you see R in your calculator, you're talking about real numbers. And there are a lot of beautiful properties of real numbers which I would like you to go and read about it, and you learn a lot about it. Because if you look at between, let's say, looking at a number line, if you look at a real number line between 0 and 1, how many numbers do you have? You get to understand that there are infinite number of numbers in between 0 and 1 in the set of real numbers. But if you are dealing with integers, you just have to, after 0 you have 1, then it continues. But for real numbers, there are a lot of numbers. They're infinite numbers between 0 and 1. So I'd like you to read about real numbers. And you enjoy it. So from here now, let's look at domain of a function. What's the domain of the function? Like I said, the domain of any function that is given to you is always what? The set of real numbers. Although there are some exceptions to it. So if you're given, let's say, a linear function, or a quadratic function, or a cubic function, then the domain of such a function will be the set of real numbers. But most of the time, if you look at questions that you're being asked to find the domain of the function, then you will notice something of this nature. Number one, let's say you have a function like f of x equals to 3x plus 2 all over 2x minus 1. Now what do you notice here? You see that this function is not a linear function. We call this kind of function is a rational function. Why is it rational? Because it has numerator and it has denominator. So, like a fraction, it has numerator, it has denominator. And still remember when we talked about rational numbers, a number that can be expressed as a fraction. So that's what you have here. This is a rational function. And anytime you have a rational function like this, then the domain of such a number is not entirely the set of real numbers. There is an exception to it. And how do we play around with that? So, looking at this function, what will be the domain? The domain was supposed to be the set of real numbers. But now, in this case now, it is not the set of real numbers. Why? Because there is a number that if you substitute here, an input number, an input value now, that if you substitute here, then this function will not exist. The function will not exist. So, in mathematics, we will say the function is undefined. It will be undefined. So we have to find a number that will make this function to be undefined. And if we find such a number, we have to exclude it from the set of real numbers so that we can have our domain. So now, how do we find a number? First of all, let's look at rational numbers again. One thing I did not see about rational numbers. If I have a rational number, let's say x equals to a all over b. This is a rational number. It has numerator, it has denominator. One thing about your denominator is that your denominator can never be 0. If the denominator of a fraction is 0, then such a number, it does not exist. There is no way your denominator can be 0. In fact, if you divide any number by 0 with a calculator, you will see math error. That's to show you that the denominator cannot be 0. You cannot divide any number by 0. Hence, looking at the rational function, we have to look at, is there any number that if we substitute into this function, it will make our denominator to be 0? If such a number exists, then we have to find it and make sure we exclude it from our domain, from the set of real numbers so that we can get our domain. So, what do we do? How do we get such a number? What you do is take the denominator of your function. Remember, this has to do with rational functions now. You are dealing with rational functions now. So, take the denominator, 2x minus 1, equate it to 0. And find the value of x that will make this particular expression here to be what? 0. Now, so this will give me 2x equals to what? 1. Because if you add 1 to both sides, so let me take it the other one. To eliminate this minus 1, we add 1 to both sides. If I add 1 to both sides, I have 2x minus 1 plus 1 equals to 0 plus 1. Right? So minus 1 plus 1 is what? 0. So I have 2x equals to 0 plus 1 is what? 1. Now from here, how do I make x to stand on its own? To make x stand on its own, I divide both sides by what? 2. So I divide this by 2, divide this by 2. I have x equals to 1 over 2. So this particular value, if I substitute it into this function, my denominator will be 0. And if my denominator is 0, it means that this function will not have an output value. Just to say it simply, it will not have an output value, meaning that it will be undefined. So in such a case now, since we know the value that will make our function to be undefined, we know the value that will make our function not to have an output value. To get our domain, we need to exclude this from the set of real numbers. So now, what will be my domain now? My domain, I can write it as, my domain is x. X here stands for any real number at all, such that x belongs to the set of real number, comma, then my x cannot be 1 over 2. My x cannot be 1 over 2. So with this, I have my domain. So this is my domain. Or I can say, my domain is all real numbers except 1 over, all real numbers except 1 over 2. So I can write my domain in this form, I can write it in this form. Anyhow, so this is it. And please take note, this only works when you are dealing with what? Rational function. Rational function. It doesn't work with any other function. It's only when you are dealing with rational function. So I'd like us to stop here for today. Another day, or in the next video, we'll now look at how to find the domain of functions that are in root form. For example, if we have a function like f of x equals to square root of 3x squared minus 2. How do you find the domain of this kind of function? Or we'll also look at the rational function, but we are going to look at what if the denominator is not a linear binomial or a linear expression like this. How do you find the domain of such function? So that's what we are going to look at in our next video. Thank you. And please don't forget to like, share, and subscribe. Thank you very much.